So we're ready to start on section 3.3 on page 134. There's the Pythagorean theorem, and I'm not sure if you have a right triangle. I didn't. What? Oh. We just, so this right triangle, 9-degree angle, this is B, this is A, C, and the square of the legs. Sum of the square of the legs equals square of the hypotenuse. And that's one of the theorems that we'll use. What's that?
Page.
What's that?
Page number.
141.
Oh, 130, so 134 is where this is, that formula's at. And then there's special right triangles on page 137 of 30, 60, 90 triangle. They start out with an equilateral triangle, and in that particular thing, each one of these angles is going to be 60 degrees. And then if you do a perpendicular bisector, the base, it goes straight up to the height. This is a right angle. So then this bisects this angle. So this is 30 degrees, 30 degrees. So what you have is you have a 30, 60, 90 degree triangle. And then the ratio of the sides is going to be given to you there on the next page. Is the side opposite the 60 degree angles, the square root of 3/2. The side opposite 30 degrees is 1/2, and this is 1. So it's always in the ratio. Similar triangles to 30, 60, 90 are always have that ratio on the sides. And likewise, if you have a 45 degree, the second special triangle, remember, these are 45 degrees, and this is 90. Then they're showing you that the ratio of the sides, they have an explanation of it on page 139. But this hypotenuse is the square root of 2. This is 1 and 1. Sometimes what you do is you do the ratio. The hypotenuse is 1, and this is 1 over the square root of 2. Sometimes you see it written that way. So with that, in addition to the other things we have, and that problem set, we'll look at that. On page 141. And number 2, and it says find the missing lengths of each right triangle. Who's going to be this is 90. And then they have x plus 4, 8 centimeters, and x. So with the information we have, what will we do?
There's no perfect on this right?
You set up quadratic, solve for x.
Well, yeah, if we think of this as A, B, and C, then what we could do is we could say A squared plus B squared equals C squared. And then we'd have x squared plus 8 squared equals x plus 4, the quantities. And then we could solve for x. So on the right hand side there, this is going to be x squared, 2 times the product of the first times the second is 8x plus 16. So the x squares are going to go out, and if we move everything over to the right, we'd have 8x plus, and by the way, this is 64. So it's 16 minus 64. And equals. Minus. That's 48, isn't it? So 8x equals 48. X equals, that's 6, right?
Mm-hmm.
So then what we have is this side right here is 6. And then this side is 6 plus 4. So our sides are 10, 8, and 6. In all centimeters. And basically you're going to do B is going to be the same way, same kind of setup. You have this one's x and this one's x, and then this is 4, where you have a 90-degree angle. So then it's just the A and B are both x. And then the C equals 4. So you have x squared plus x squared equals 4, 2x squared, and x squared equals 2, and x is going to equal, and it's plus or minus, so, but it's positive, square root of 2. So that would be B, and then the C one, and it's just the application of the same. Here's your right angle. That's 13. And you could just say A is this is B, and this is C. And then the Pythagorean theorem, you'd have x minus 10 squared plus x plus 11 squared equals x plus 13. So this is like x squared minus 20x plus 100 x squared plus 22x 121. 26x. Let's see, 13 things. 13. What is it? What is it? 169. So on the left we have 2x squared plus 2x plus 221. That's x squared plus 26x. 69. We get everything on one side and 0 on the other. So if I move everything to the left, then I have x squared. And then that's a minus, that's 26, that's 24x. And then plus, what's that, 2, 5. Is that right? Then we factor that by trial and error. It's x and x, and it's both negatives, right? Because same sign, which sign? Minus sign. Okay, what two numbers times itself is 52? Sum is 24. What is that? 2 and 26. What's it? Two and 26 don't work. 3 is 3 a factor. 3 and no. 4. 4 and what? 13.
26 and 2. Professor, that's it. Negative 26, positive 2.
No, but they're both the same sign. It's, yeah. They both, you have to be a sum. Sum is 24.
Wow. 13 times 4, but that's not going to give you the middle
No.
value.
They don't factor by trial and error. I didn't know it was this complicated. But anyway, then what do we have to do? Either quadratic equation or else completing the square. So completing the square is what I like. Move the 52 over. Take half the middle term, square it and add it. And then do the same thing over here. Now you got x minus 12, the quantity squared, equals a minus 52 plus 144. Is that right? Is that 92? Is that right? Am I doing my math right? Yeah. X minus 12 equals plus or minus the square root of 92 plus 12. Add the 12 to both sides. And let me just 92, see what does that factor out? 2 comes out of there. 2 and 46. 2 times 2 times 23. So this is going to be 2 square root of 23, right? Plus or minus. So x is that. And we're supposed to, and then the one side is going to be, one is x minus 10, one is x plus 11. The other,
Take out two twos, right?
what's that?
You took out two twos and you put 23. Is it not supposed to be 4 root 23? Supposed to take out two twos.
Oh, 92 factors into 2 times 2 times 23, don't it?
Yeah, I thought it's
And then a
supposed
2 comes out from underneath, so then you got 2 square root of 23 left.
to- okay.
And now that's going to be
Yes.
12. Is that negative a positive number? That is 12 minus 2 square root of 23. Is that a negative number or positive?
For change.
It's possible.
Well,
Hmm.
in the
So you have,
positive.
I mean, what you have is you have the possibility of 6 different answers. One is going to be using x is equal to 12 plus 2 square root of 23, and one is using x is equal to 12 minus 2 square root of 23. And then you plug in for x on each one of these.
Wait, we don't have to use the minus now because x can be negative, right?
X can't be negative.
Yeah.
No, and that's what Bailey said, that this is a positive number.
Oh.
And then this obviously, this is a positive number, and she said this one's a positive number. So you'll have 2 different values of x.
Yes, that results in a positive number. When you do x minus 10, it's not going to be a positive number.
Okay. That's a good point. So this one we cannot use. So then it's going to be this one. So we go 12 plus 2 square root of 23 plus 10, which is 22 plus 2 square root of 23. That'd be 1. Then it'd be 12 plus 2 square root of 23 plus 11.
Nice.
I think that first one I did wrong because that was minus, this is plus. So it's 12 minus plus 2 square root of 23 minus 10, which is going to be 2 plus 2 square root of 23. So that'd be one side. And it's 12 plus 2 square root of 23 plus 11 equals 22 plus 2 square root of 23. And it's 12 plus 2 square root of 23 plus 12. That's going to be 24 2 square root of 23. So that would be the sides. Okay. 4. says find the areas of the polygons with dimensions shown. So the first one, looks good. Okay, and they're saying that this side equals this side. This is 10, and then this whole length is 20, and it's meters. And then this side is 13, and then we have this is called age then.
Does that make those two sides 5 and 5?
What's that?
Does that make those two sides 5 and 5, or you just have to use Pythagorean theorem to find sides?
Well, you know, logic would say that it's 5 and 5 because if you have an isosceles triangle and the bottom is 20 and the top is 10, then
Yeah.
these two pieces
The 5 and 5.
over here have to be 5 and 5. That's using reasoning to do it.
I'm just saying.
Okay. But what we need, they want the area, right? So what we need to calculate is we need to calculate this. So any ideas?
Yeah, we can solve for h.
So how are you going to do it?
169 on one side, the hypotenuse, 13 squared.
Okay, so what you're going to do is you're going to call this one C, this one H is A, and then B is this length.
Right.
And Toby said this was 5.
Mm-hmm.
So H then is going to equal the square root of C squared 13 squared minus 5 squared. It's C equals the square root of A equals the square root of C squared minus B squared. So this is 169 minus 25. So that's 12, right?
Yep.
So now the area formula is what? 1/2 base 1 plus base 2 times the height. So then it's 10 plus 20 times 12. So that's 15 times 12. Is that 180?
Yes.
So this is the answer. And then the B part.
Oh, okay.
Oh,
Yeah, I'm good, thank you.
okay. B part. And we have doesn't look like it's a regular 6-sided hexagon. And then we have let's look at the grid. Let me say this is 6. Here's H. And here's 3 and 3. And we want the area. So what's the formula? It's 1/2 of what? Perimeter times H.
And H, so
Right. So how are you going to calculate H?
what's that going to?
Well, you know, if you used H is equal to A, 3 is equal to B, and 6 is equal to C, then what you have is H is equal to the square root. Well, it's going to use this relationship. That I guess I'll write A squared equals C squared minus B squared, so that A equals the square root of C squared minus B squared. So H then, and it's going to be positive, we don't want to do negative. C squared is 6 squared minus 3 squared. 36 minus 9, 36, 39, 36 minus 9, 17. That's a nice number.
No, 27.
So
27. So then that's 3 cubed, isn't it? Is that right? So then this is 3 square root of 3. And the parameter is going to be 6 times the 6, right? 1/2. The parameter is, there's 6 sides, each 6 something inches long. And the height is 3 square root of 3. That's inches. So if I do this, it's 3, so it's 18 times 3 square root of 3. 54 square root of 3. Is that right? As far as I'm concerned, you know, if you use decimals, that's just a rounded off number.
you have base 1 and base 2 as 6.
What's that?
For the two, just the base 1 and base 2, you have it as 6, 6.
Well, so there's 6 sides, right? Each six sides 6 inches long.
Oh, okay, I get it.
And I just divide the 2 into 6 and got 3, and so I didn't have such big numbers. Okay. 6. What do you think? Can you do 6? 6 is just applying A, B, C. You know, it's a right triangle, and they're giving you I guess I can do it. The first part, you're going to have to do a side. The perimeter and the area. So if we wanted to do a squared, that's going to be c squared minus b squared. 7.65 squared minus 4.81. And then a is going to be this. So 7.65. So this would be, that'd be a, that'd be one answer. Then the p, the perimeter, is going to be the sum of a plus b plus c. So it's going to be the square root of 7.65 squared minus 4.81 squared plus 4.81 plus 7.65, and then the area is just a times b, right? 1/2. And a is this thing. Times the b. 4.81. Right. When I switch over to my calculator, I'm not going to be able to see this. 7.65 squared minus 4.81. So second square root 7.65 squared plus, was it 4.81?
4.81.
So that'll be that side A. Then the perimeter is going to be, we're going to add that A to 4.81 plus 7.65. So that'll be the perimeter. Then the area is going to be that thing times 4.81. And it'll be that. I don't do intermediate steps and don't round things off. I simply put it in,
Right.
because this is A times B.
First equation should be minus.
Okay, sorry. So I'll go up here. Bring that, this one. Then I'll bring that one down. Then I'll go back in, change it. Minus. Put this minus in. Back up. Dang it. No, how do I do that? Delete is not going to do it. 6.5. This has got to be a 5. And it's got to be squared. Then delete that. Then I go forward. Now I do minus. Now it should work, shouldn't it? No, something's wrong. I hate it.
Have to delete that.
Delete that.
There we go.
Now, then enter. Okay, now we got that. So then that's A. Then the parameter is going to be that thing plus 4.81 plus 7.61.
Mhm.
And then the area
That's
should
more like
be,
it.
then the area should be this one times the 4.81. Is that right? So then the B part.
So we need to divide by 2.
Oh. Go back. So I'll go divide by 2. Now we got it, right?
Yes.
Okay. Ooh. Okay. Now it's given us A in the area, B part. So what we're going to do to find B, it's 1/2 of A times B equals the area, right? So B is going to be 2 times the area over A. So it's going to be 2 times 78.23 over 10.55. And then C, that'll be B. So then C is going to be A squared plus B squared. Square root. Right? And this is A is 10.55 squared plus that deal up there. That 2 times 7.823 over 10.55. And that should give us C. Then the parameter should be A plus B plus C. So it's going to be 10.55 plus, we go up and highlight this, right? And then we highlight this thing. Okay. See if we can remember how to do this. Clear. So the first thing we're calculating is B, and it's 2 times 78, isn't it? 2 times 78.23 divided by 10.55. Is that right? Was that right? Do you concur, Bailey? Was that right?
Mhm.
Okay. So that's B. That gives us B. Then the C, we have to do what? Second square root of that thing up there, right? Squared. So that's squared plus the 10.55 squared, right? Squared. Okay. Am I ready to hit enter? So that's C. Then the perimeter is the sum, right? Sum of this one plus this one plus 10.55. Is that right? Okay. Okay, I want to, you can do those C and D. I'm going to look at 8. 8. We have these, and looks like an egg. We have these two circles that are same size. And we got this. Really good. Okay, then we have this center, that center, and that center, and we join those. And they say the areas of the two large circles are both 25 pi. So the area here is 25 pi. Area here is 25 pi. And the area of the triangle is 6 centimeters. So this area right here, I'm going to leave the units off because the units are all the same. And it says find the area of that little circle. So what do you think? What's the strategy? Well, we can find the radius, right? We can find this value right here, this R value right here, this R value here, the distance right here, this R right here, and this R right there, correct? By using the formula for area. The area of a circle is pi r squared. That's 25 pi. So r squared equals 25. R equals 5. So each one of these are 5. Correct? Now if we do this height right here, from here down to here. You see where I'm going? If I find that height, then I can find the hypotenuse, the distance r plus that little piece. Then I can find the radius. So this height right here, I can calculate by doing this area right here, correct? That's a triangle, and that's 1/2 of the base times the height. And in that equation, I have 6, 1/2, the base is 10, and the height is going to be h, right? So the height is going to be 2 times 6 over 10. Okay. 6/5. Is that right? Everyone with me on that? Now then, the distance from here to here. There's a right triangle where h is one leg, 5 is the other leg, and that distance, I'll just call it k. It's this distance right in here. So k, and that's the hypotenuse, right? Is equal to the square root of the legs, sum of the legs. So it's the square root of 5 squared plus 6/5 squared. I'm not going to calculate that. I'm going to leave that to my calculator, but this, I didn't draw it very good, but this point right here is the tangency of the small circle and the big circle. So if I subtract my k, if I subtract the r from the k, I get the radius. That
Of the little circle.
Yeah. So the radius of my little circle is equal to k minus r. And that k is right up there, so it's k minus 5. And then I'm going to use that k minus 5, the area of the small circle is pi times r2 squared. Okay. So I'll leave you to put the numbers to it, but that's how you do it. There'll be a quiz on Wednesday.